Okay, in this video, I'm going to solve another problem about hydrostatic force on curved surfaces. Here's the problem. The gauge shown in the figure is 6.1 meters long. What are the reactions at the hinge O due to the water? Okay, so again, the length is 6.1. Now, since this is a curved surface, we have to compute for the horizontal component and the vertical component. So, for the horizontal component, we just get the vertical projection. So, this one. So, just get the vertical distance from B to C. That portion only which is in contact with water, okay, or the liquid. So, vertical distance from B to C is 2.13. The length is normally 1. Kaya gina-assume siya na 1 unit. But this time, the length is given. So, this is 6.1. Okay. So, we have this one, 6.1. And then 2.13. So, the area is 12.993. Okay. H bar, this is the centroid. Center of gravity, like, rather. And H bar is 1/2 of 2.13, since this is the free liquid surface. So the horizontal component is gamma. In SI, that's 9.81 kilonewtons per cubic meters times H bar 1.065 meters times area na 12.993 square meters. And the magnitude of the horizontal component is 135.746 kilonewtons. Now, it is directed to the right since the liquid is to the left of the curve. Now, for the vertical component, we get the area. So, from the curve, those that part only which is in contact with the liquid. So, B to C, no? So from B to C, i-project vertically upward, ipa-intersect sa liquid surface. So for B, no need na kay mo intersect siya sa liquid surface only. C, so mag-draw kag line eh. Okay, so this is the area. Okay. So we now compute for the area of this one and then multiply it by 6.1 in order to get the volume. Now, how do we solve for this area? We start with this sector. Okay, so from the center, the sector is this one. OCD, that's a sector. So this area, the shaded part, is equal to sector minus triangle. Okay. So OCD sector minus this right triangle, the result is this area. And we need to compute for this angle. So you solve na to, and we use trigonometry. This is 0.91, and the radius is 3.05. And to solve for theta, we use cosine. Cosine of theta adjacent 0.91 over hypotenuse. Okay, so theta is 72.641. And from here, we can solve for the area. Now, for a triangle, the formula to the formula that we will use is 1/2 times product of two sides times the sine of included angle, and not 1/2 BH because we don't have the value of the base. So the area is area of sector 1/2 r squared times theta, this one, central angle, convert nemo to radians, times pi over 180, sector minus triangle 1/2, product of two sides, 0.91, and radius times sine of the included angle. So included angle means angle between the given two sides. This one, theta. Okay, so the area is 4.572. And we're gonna solve for the vertical component is gamma times V, and volume is area times length na 6.1. This is gamma and volume area times length. The value is 273.593. And since the liquid is below the curve, it is directed upward. So therefore, ang reaction sa hinge at O is just to balance. So ang horizontal component is directed to the right. So ang horizontal component sa reaction sa O must be directed to the left. And ang vertical, since ang vertical component sa hydrostatic force is upward, ang vertical component sa reaction is downward. This is left, and vertical component is downward. Okay. So for curved surfaces, sometimes the most difficult part is in the computation of area sa so that area needed in the computation of the vertical component, and it requires background sa solid mensuration or plane geometry. So that's it. So I hope that you have learned something from this video. Thank you for watching.